Hello, welcome to week 5 of our revision. This week we're looking at LANs, WANs, topologies and hardware used on networks, and this is paper 1. Okay, make sure you've got sheet 5 given to you in lesson, have it in front of you, ready to complete. Okay, so to start with, let's remind ourselves, what is a computer network? It's anywhere where there are 2 or more computers and devices that are linked together. Could be 2, could be hundreds, could be thousands. And it allows data to be sent between the different devices and computers connected. First type of data network we know about, which we covered, is a LAN, a local area network. A network that covers a small area of land, a small geographical area located on a single site, like in a school, a small business, or a home network like you might have at home. All the hardware in a LAN is owned by the organization. It's not rented, it's owned by the organization. And it could be wired or wireless. So why use a LAN? What are the benefits of using a local area network? Well, you can share files easily. You can share devices like printers. You can share an internet connection. Those are your 3 easy ones. Share files, share devices, share internet connection. It's also easy to install and update software and things because you can do it from one computer. You can communicate and monitor users on the LAN easily. And you can log in from any device that's connected if it's stored in a central location. Oops. Okay, key ones there though: share, share files, share hardware, share internet connection. Easy. Okay, the second type of network is a WAN, a wide area network. Basically, that is multiple LANs, more than one LAN, connected together in different locations geographically, different geographical locations. Could be within an area of a country or even around the world. Okay, as long as the LANs are in different locations and they are connected. So, multiple LANs connected in different geographical locations. This could be, for example, a business that's connecting together different offices in different cities, or even multiple schools that connect together to form a larger network, a wide area network. Remember, a LAN owns and uses its own hardware. However, in a WAN, some of the infrastructure, things like the telephone lines, the communication lines that connects the LANs together, are hired. Things like hiring a telephone line from BT to use their internet connection to connect them up. It is more expensive to set up and run a WAN than a LAN because you have to hire things, you have to use special equipment to connect the networks together. And WANs could be connected using copper cables, fiber optic, satellite, or even radio links if there's short enough distance between it. And remember, the biggest example of a WAN is the internet. The internet is a worldwide network, wide area network. So on your sheet now, fill in the sections on LAN and WAN and check on the next part of the video in a minute. So here we go. LAN, a network that covers a small geographical area on a single site and all the hardware is owned by the organization. Share hardware, share internet, share files. They're the easiest ones to remember. Remember, a WAN is a network that connects different LANs in different geographical locations. And it covers a much wider area geographically, and some of the infrastructure is hired, like the communication lines. Checking your answers with Purple Pen Improve. Okay, so now we know what LANs and WANs are. How does a computer network work? Well, remember, the layout of devices on the network is called the topology. All the hardware, how it's laid out and connected, is the topology. And there are different topologies that exist and have existed. However, there's only two that I really want you to focus on for this exam. There is a star topology and a mesh topology. They're the two to focus on for this. A star topology is where all the devices have their own connection to a central switch in the middle. There's a central switch in the middle which connects the devices, and it could be wired or wireless. In the middle there, a central switch, remember. The good thing is though, if one device fails, like this computer here from the bottom, the rest of the computers will keep going. They are fine. It's very simple to add more devices, and there are very few collisions of the data because it's being directed by the switch in the middle. However, if the switch in the middle breaks, or the server breaks, the whole network fails. And in a wired network, you might have lots of wires, which can be quite expensive too. The other type of topology that you need to know about is a mesh. This is a newer design for a network. It is decentralized. That means there is no center point in the middle. There is no central point with a switch in the middle. All the devices connect either directly or indirectly to each other, and data is sent along the fastest route available. Good things, advantages, there's not one single point where the network can fail. There's no central switch or server that can break. And it is quick because data is sent along the fastest route or path. However, it can be quite expensive to set up with lots of cables if you're using cables. But wireless would be easy and cheaper. Remember, there are two different types of mesh. There is a partial mesh where only some of the devices are connected together, and there is a full mesh where every device is connected to every other device, but a lot more cables than that. So on your sheet, topology, star, mesh. Fill in the sections and then check on the next part of the video. Okay, checking your answer with Purple Pen. Topology is the layout of the network, the hardware. A star is where devices are connected to a central switch. If one device fails, the rest of the network keeps going. It's easy to add more devices. And if the central switch fails, the whole network stops. Mesh is decentralized. There is no central switch or server. There is no single point where the network could fail, and you can still share devices like printers and things. However, there are lots of wires if it's a wired network. And difference between partial and full: partial, only some of the devices are connected. In a full, all the devices are connected to each other. Okay, last section. So we know what a network is, we know the layouts, the topologies, the main bits of hardware that you need to know that are used in a LANs and WANs. Well, this one here is a network interface card, or a NIC, network interface card, or controller, sometimes it's referred to. Every device that connects to the network has to have one of these. Okay? It can be wired or wireless. A network interface card has a fixed MAC address assigned to it, a bit like a postcode, so that the device can be found on the network. MAC address, which is a hexadecimal address, and you cannot change it. This device here, this is a switch. Every device on the network would connect to the switch, connects all the devices on a LAN, local area network. It knows the address, the MAC address of all the devices connected to it, a bit like a post office that knows all the devices. It receives data in units, little chunks or datagrams called frames of data. And it directs the data to the place it needs to go to by reading the MAC address. Data comes into it as frames. It reads the address of where it needs to go to, and then directs it through the switch down the correct cable to where it needs to go to using the MAC address. MAC address. And this one here, you might have one of these at home. This is a router. Difference is this transmits data between two dissimilar different networks. For example, a LAN to a WAN. Okay? Very important on the internet because they direct data from different networks on the internet. And they are used in your home or offices to connect your home LAN, your local area network in your house, for example, to the internet, a WAN. Connecting two different networks together. And finally, a wireless access point, a WAP. A WAP or wireless access point is a device that lets you connect to a network wirelessly. Okay? In a LAN, it connects devices wirelessly to the network, and it uses a standard, a protocol called Wi-Fi. Data is transmitted wirelessly using radio waves, and every device that's connected needs a wireless NIC to connect to it. Okay? Wireless access point, Wi-Fi, transmits data using radio waves. Data sent through the air as radio waves. Different frequencies, it can either use 2.4 gigahertz or 5 gigahertz. We will look at that later on. On your sheet, what is the purpose of each of these devices and a couple of key facts about it if you can. Okay, checking your answers. Network interface card is used to connect devices to a LAN, and it has a unique fixed MAC address, so a device can be found on the network, and it can be wired or wireless. Switch, it connects all the devices together on the LAN. Directs data on the LAN by reading the MAC address of data, and it receives frames of data and transmits it onwards. Router transmits data between different networks, for example a LAN to a WAN. Key bits here, please add this to your answer. A router uses IP addresses and it has a public IP address for the network. So from outside a network, the router would have a public IP address that the internet could see. And it directs data by reading the IP address of packets of data. We look at that more later on as well. And finally, the WAP, the wireless access point, allows devices to connect to a network wirelessly using the Wi-Fi protocol. Transmits data using radio waves, and it can be either 2.4 gigahertz or 5 gigahertz. We look at that again later on as well. Checking your answers with purple pen, please, adding to it. And finally, you've done the sheet, ready to show me a lesson. Go to Learn Cum Dean, under revision, and you're doing revision quiz 5 this week. Revision quiz 5. As always, check each answer, improve, try again if you do not get it correct. You should be aiming for 100% by the end of the quiz. Good luck. See you in lesson.